What is up, folks? This is Mr. Walker coming to you today with our notes for our new class. Sorry about the noise. That's my cat. She's just being a little stinker right now. So, we are talking about congruent triangles. You want to stick up here? Yeah. All right. So, congruent triangles. Just like how we had reasons why triangles are similar, we're going to be going into reasons why they are congruent. All right. Don't get all up in the mouth, Mike. Come on. Yeah. All right. So, let's talk about a couple things that are different. All right, let me go through and mute that while I'm at this. All right, so the congruent symbol, if you remember, is the equal sign with our little similar symbol on top of it. Okay, so please remember that this symbol here is different from when we were just talking about similarity. All right, now for two shapes to be congruent, two figures, to anything to be congruent, they are congruent if and only if the corresponding sides are congruent and the corresponding angles are also congruent. Now, congruent means the same. They are entirely the same. Same measure, same shape, same everything. So if your corresponding sides and angles are congruent, then you have two figures that are congruent. Congruent figures can be mapped onto each other through a series of rigid motion transformations. And that's going to be something that we're going to talk about later on in this unit. So that's things like translations, aka sliding the shape around, reflections, aka flipping the shape around, and rotations, aka turning the shape. So, main thing for you to understand is that they're the same shape and the same sides. Okay? Now, just like when we talked about with figuring out which sides corresponded to each other for similar shapes with congruent shapes, the names that we have also help us out with that as well. So we have in this example, triangle ABC is congruent to FGH. When we look at this, we know that the first letters in these match up. Therefore, their angles here are also going to match up, meaning that they're going to be the same. Same thing with B and G, and same thing with C and H. So, as a whole, everything that we know is congruent here are the following for our angles. Let me make sure I go through, get that out the way. So, A is congruent to F, meaning those two angles are the same. B is congruent to G, therefore those two are the same. And C is congruent to H. Now, just like how we use these arcs in the previous couple units, we'll have them on these so we can indicate what angles are the same. Now, along with the angles being the same, the corresponding sides are also going to end up being the same. So we have AB to FG. If you look at their names as well as where they're positioned, they are in the same place on both triangles. You can also tell by looking at the marks on the angles to be able to tell that since I see these two marks here, for this one with a 1 arc and this one with a 2 arc, it should match up over here with the 1 and 2 arc, meaning that side that's in between those should be what corresponds. Likewise, we got BC to GH and CA to HF. Now, keep this stuff in mind. The whole idea with being able to look at the names of the shapes as well as the markings on the shape is that we can go through and not only write out what sides are going to be corresponding, but also be able to set up any math to discover any missing parts. So, let's take a look at a little bit of practice, people. So, in our first round of practice, we're going to be completing the congruent statement by using the pictures that we see here. Okay? So, in our first one, we have triangle KLT. That's this one laying here on its side. We're trying to determine what is the name of the triangle that corresponds to it. So, we have to make sure that we look at the name so we can look at the right place. First off, look at KL. KL has one little mark right there, one little hash mark. On the other triangle, the same side will have that same marking. So that mark is right over here with E and Y. Now, after I look at KL, if I go from L to T, that side has 3 marks. The side over on the other triangle that has 3 marks is E to J. And then just like how those two matched up, from J to Y will match up from T to K. So if we can go through in that same motion from KLT, we can say that this is congruent to YEJ. So we look at the markings, and then we can go through and say what is congruent to what and make up the rest of our name. Now, on our other triangle here, we don't have 3 markings here, but we do have 2 hash marks on 2 of the sides, and we have an arc on our pair of angles here. So our triangle that we're first looking at is WRB. W comes up to R, then comes down to B. From W to R, we see this little 2 marks on this side. So I'm looking for what side has 2 marks. For this, it goes from P up to N. Now, when we came up to R on our other triangle, we had 1 marking on that angle here. So if I come from P to N, I have that same marking happening over here on N. Then on the other triangle, I went from R down to B, and I saw that there was 1 mark on that side. So as I come from N down to C, I see that same mark showing that that and that correspond, just like how this and this correspond, just like how that and that correspond. So if my name for the first one was WRB, the other one is going to be PNC, just like the bank. So you just go through and look at the markings, and then you can be able to tell what sides correspond. Now, along with naming these, we can also use these names and these markings so that we can be able to determine some math. So, on our next pair of examples, we have triangle MEU is congruent to RVH. Now, they want us to use this in order to find angle ME. Not angle, sorry, side ME. Now, ME is right here. And if I look at their name, ME matches up with RV. So, ME and RV, I'm going to go through and highlight those the same color. So, ME is this side right here that I've highlighted in yellow. And RV is this side also here that I've highlighted in yellow. Now, I need to figure out what this side is by using the information that I see so far here. I know that I see that on triangle RVH, 2 of the sides have X's. And I also know that because these 2 are congruent, I can use the fact that the side that I do have from MEU corresponds with, not MEU, sorry. The side from M to U, which is the only thing that we have marked over here, 14, MU would correspond with the side from R to H. So, if that's the case, I know that this side here with 14 corresponds with this side here with 2x minus 4. All right, let's set up some math. These 2 sides correspond, and these 2 triangles are congruent. Therefore, these 2 sides are congruent, which means that they're going to be equal. I now set up my math. I got 2x minus 4 equals 14. I got to add the 4 to the other side, which gets me 2x equals 18. And then I divide both sides by x, giving me x equals 9. Now that I have x, I can use that to plug that into the other side for VR. VR is x plus 3, so I just substitute the x with a 9, which means that VR is 9, not 9. VR, don't goofed up, people. Gotta love typos, people. So VR from this means that this is equal to 12. Let me go through and make sure that this looks a little cleaner. And 12. Boom. Now this side is 12, and I know the yellow sides match up, that means that ME is also 12. Okay? Sorry about that little typo, people. Sometimes things happen. So, now that we got that, you can tell from the names of your congruent shapes how you can set up any of the sides that you want to go through and find anything that's missing. Along with sides, we can use that same logic to help us out with angles. So, I see for my next example, triangle ABC is congruent to KLM. They want us to use this information to find the value of X. Now, we're talking about triangles again. We know that inside of the triangles, we have three angles, and all three of those add up to 180. Now, if these angles add up to 180, then that means that these angles that are congruent will be able to help us set up the equation that we need. I know that A matches up with K, and they're both 90 degrees. B, which is up here, matches up with L, which is right here, which means that if L is 60, B is also 60. Now, the last thing that we got is C, and C is in the same place as M, which means that if C was 3x, M is also 3x. All right, now that we know this information, we could use this to set up our equation to find X. Let me get over here. So, I know for me to find angle M here, I take the information that I have, and I could look at just that small triangle there, which is with the 60 degree and the 90 degree angle. If those two add up to, if those two and that missing angle add up to 180, I could just subtract 60 and 90 from 180, give me that angle M is 30. Now, if the angle M is also 30, and it corresponds with angle C, that means that we can say that these two are equal. Now, if C is also equal to 30, that means that 3x can be said equal to 30. And if I divide both sides here by 3, my x is equal to 10. So we just take our time being able to go through and set up the math accordingly. All right, so along with us knowing the facts for congruent triangles and how to set up the information, you might, be a little bit remiss to think, oh, do I have to set up every single thing from the rooter to the tutor to figure out all this information? The good thing that you need to know is you do not need to prove all 6 of the things that we know about congruent triangles. You do not need to prove every side is equal or every angle is equal. We only need a little bit of the information in order to go and jump into proving that these are the same. So, there are a couple combinations of congruent parts that we use as shortcuts to prove that triangles are congruent. This is kind of like the shortcuts that we had back with proving that triangles are similar. Except for this, there's a bit more that we had to go through. Okay, a couple more shortcuts, so don't freak out. We always use our notes. We're going to build up some knowledge on this. So, our first little shortcut is the side congruence postulate. Basically, if you can prove that all 3 sides on one triangle are congruent to all 3 sides on another triangle, then you can say that the triangles are congruent. We also have the side angle side congruence postulate. This means that I need a side, an angle that's in between it, and another side. So basically, these 2 sides are the side that make up this angle. If you can prove that all 3 of these are equal between 2 triangles, then you can prove that they are congruent. We got angle side angle, which means I need 2 angles in their included side, the side that they share together, need to be congruent. We have angle side, which is 2 angles, then the following side have to be congruent. And then we have the hypotenuse leg congruence theorem. This last one here is specific to right triangles, okay? Don't freak out too much. We got this, all right? All right, so Let's go into a little more detail about these first two right here, okay? The first two we got here are the side, and the side, angle, side, congruence postulate. So for our first one here, oops, sorry. Hold up. Wait a minute. There we go. So for side, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So for this to work, I have to prove that for these two triangles in this example, if AB is congruent to FG, and if BC is congruent to GH, and CA to HF, then I can say that these two triangles, ABC and FGH, are congruent. Now, if that's the case, we have to be able to set this up using some math and using our know-how from triangles so far. So don't feel any type of way. We're going to be able to get through it. All right. Next one we got is the side angle side postulate. So if two sides and the included angle of one triangle are congruent to two sides and the included angle on the other triangle, then they are congruent. So in this, if I have AB and FG, and they are congruent, and I have this angle up here, B, and this angle over here, G, if those two are congruent, if the other side that makes up those angles, aka BC and GH, are congruent, then I can say that these are going to be congruent. You're not going to really end up in anything that I'm going to give you like an okey doke on. The only thing I will have you do is you'll need to verify if these are in fact congruent using any of the math and any of the knowledge that we've seen from so far. So far, let's go through and look at these three on the bottom. All right. On the bottom is asked which postulate, if any, could you use to prove the two triangles are congruent? So, looking at this first one, we got this angle, this angle, this angle, and these angles here. Can we prove that these are congruent? The only types of ways that we can prove so far from our list are side, side, angle, side, angle, side, or the hypotenuse and leg. Unfortunately, there's no information here about sides. There's only information about angles. We can't really say for a fact that these two triangles are in fact congruent because we do not have any information about the sides. We could say that these two here are similar, but we're not trying to prove similarity. We're trying to prove congruence. So, for our next one, we got these two triangles here. I see that there's some information about the sides. This side here with the two marks and this side over here with the two marks are both marked the same, therefore they are the same. Likewise, this and this have the same markings. If they are the same, then they are the same. Now, we're going to need something else. We either need another side or an angle. If you notice in the middle, we got us a nice good old pair of vertical angles here where those two lines cross. Because of that, we have a side, an angle, and a side that are congruent. Therefore, we could say that this is congruent based off of the SAS postulate. All right. Now, for our last triangle here, I see that our two sides here on the bottom are marked the same. Our two sides here on the left and right are the same. We need a third side that's the same. Since these two both line up and have this side here in the middle in common, this means that this side is congruent to itself, which means that we can say that these are congruent based off of the SSS postulate. All right, people, this is our first page of notes. We're going to get into the continued part of this, okay? If you need to take a break, pause the video, come back in. Let's go through and get it, okay? All right. On our continued part of our notes, we have the other three theorems that we're working with. First one we got, angle, side, angle. So, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So if I'm looking at one angle, let's say if I'm looking at B and G, and then I go to one of the sides, so BC and GH. If these two are congruent, and then this third angle here, C and H, are congruent, I have the stuff that I need to prove that this is congruent based off of the angle side angle postulate. So I would say triangle ABC is congruent to FGH. All right. Next one that we're getting into, we got the angle side angle theorem. Sorry, not angle side angle. Angle side theorem. Sorry about that, folks. If two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. So if we have two angles on our triangles, let's say we're looking at A and F and B and G, the non-included side is a side that's not in between these two right after we get past G. So if I go up from A to B or from F to G, my non-included side would be BC and GH. So it has to be in this particular configuration for this. All right. No, it's a little confusing because these two do share the same letters, but just be aware this has to be an angle, then a side, then an angle. This has to be an angle, and then a side. All right. Just keep that in mind as we go through this. So, because this is the information that we have, we could say that ABC is congruent to FGH. Okay. All right. Last but not least, we have our friend the hypotenuse leg theorem. Now, the thing that you need to know, hypotenuse and leg are specific sides that we have for right triangles, okay? Right triangles, if you remember, have a right angle in one of these two sides. Well, sorry, in one of these three angles for these triangles. Ugh, sorry about that, folks. So, for this to work, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So if BC is congruent to GH, these are both the two hypotenuses, aka the sides that do not touch the right angle. If those two are congruent, and I have, let's say, CA and HF, if those two are congruent, and if the angles that I have in there, if I have two right angles, a right angle in one triangle, a right angle in another triangle, then ABC is congruent to FGH. Okay? All right. Couple reminders that we got here. Included side, if you ever see that word, that means that the angle formed by two sides needs to be used for this. Okay? So this is specifically if we're messing with the SAS theorem. All right. You'll just basically have an angle, and then the two sides that make up that angle have to be congruent to another angle, and the two sides that make that one up. If we're talking about the included side, that means that the side that's in between two angles is being used. And this is for the ASA theorem. All right. So it has to be the side that's in between two congruent pairs of angles. Now, the only two things that we're going to make sure that we don't use for proving that these are congruents are AAA or SSA. Okay, these don't really prove to us anything that we need to say that two triangles are congruent. So stick away from these. All right. We got a little more practice, people, and then we're in the home stretch. We got two more slides. All right. First one we got here. Which postulate, if any, could we use to prove that two triangles are congruent? All right, over here, I see I have this angle and this angle are the same. This one side and this one side are the same. Do we have another thing that we can say is the same before we start using our reasons? If you see in the middle where those two cross, you might have recognized that as a thing that we've had before. This is a pair of vertical angles. So what we have here is an angle, then another angle, and then a side. So this means that we have the angle side theorem. On our other triangle here on the right, we got to prove, again, do we have two sets of congruent triangles? So let's look. I know that this side that's in the middle is the same as itself, but do these make up one of our theorems? I see I have a side, then an angle. Do we have anything that works like that? Unfortunately, we don't. If this were this angle over here in between these two sides, we could say that this would be side, angle, side. But unfortunately, because this is not in between these two, or these sides aren't necessarily going to warp around these angles, we can't say that these are, in fact, congruent. So far, we got one that's congruent. Let's check our next one. Next one, I see I got two right angles in my triangles. I also see that the hypotenuses, the sides that don't touch the right angles, are both marked the same. Now, do we have one of our legs that's the same between these? You notice, just like how we've had before, if these triangles line up on a side, that means they share the side. So this saying right here in the middle is shared in between these two. Because of that, we have a hypotenuse that is congruent and a leg that's congruent, which means that these are congruent based off of the HL theorem. All right, last one on this side. Home stretch, people. We got one more after this. I see that I got a pair of vertical angles right here. Anytime you see that crisscross action, we know that those are going to produce some congruent angles. Hey, Mimi. Good to see you. Sorry, my cat's here to visit again. So I see that I got that angle in the middle. I got a side. Okay, well, all right. Okay, don't get all over there we go. Come on. You're killing me. All right, so uh, my cat has spoiled the answer. This is the ASA postulate. That's because we have a angle here, then a side, then another angle that are congruent between these two. Okay? All right. Hush. All right. We got three more. These are the ones on the bottom here. Okay? For our first one, we want to prove that these two triangles are congruent. First off, I see that, Lord, you see these arrows on these sides. Whenever you see those arrows, that means that we have parallel lines. Now, parallel lines have different congruent angles. So if this top side and this bottom side are parallel, that means that this angle here and this angle here are alternate interior angles. You could also say that this angle here and this angle here are also alternate interior angles. So we have two pairs of congruent angles. We also have this side in the middle that both of them share. So because they both share it, that means it's congruent to both of them. This is going to be congruent based off of the angle side angle postulate. We have more than a couple pairs of angles, and we have a side that is congruent between the two. All right, for our next one, we see two sides that are marked the same. We got two angles that are marked the same. Do we have anything else that we already know is the same? We've seen a couple of these overlap ones. I don't want you to lose track of things like this as we go through. This little bit of overlappage means that these two sides here are in fact congruent. So that means that we have a side, then an angle, then another side, which means we have the SAS postulate. All right, our final one, and then we're out of here, people. We see that on both of these triangles. We got an angle and an angle that are marked the same, and then we have a side that's not included between these that is marked the same. If we have an angle, then a side, that means that we have the angle side theorem. Folks, I appreciate you coming in to check out your notes. Hopefully you get this into your book and answer your practice questions, and I'll catch you later. Have a good day.